Hi, here's some video help for section 2.2 homework. This is number 11. So this is a compound piecewise function, and we're going to have three different things going on here. This is going to be a line 1 plus x. It's part of a parabola and another part of a line. And notice we're going to have some open and closed circles going on. So if you're not really sure what to graph, a hint that I have for you guys is you can make an XY chart. And then I want numbers that are less than -1, not including -1. So what you can do is just kind of remind yourself, hey, this -1 is going to be an open circle, and then I'm just going to pick a couple numbers that are smaller than -1. So if we plug -1 into this function, 1 plus -1 is 0, 1 plus -2, 1 plus -3. Okay, so I'm going to go ahead and graph that. So -1, 0 is my open circle. -2, -1, this is just a line. And -3, -2. And then this is going to kind of continue on forever, so I'm going to draw that arrow. So there's that partial line. Okay, we want to go x squared from -1 as a closed dot to +1 as an open dot. So you probably don't need to make a chart, but I'm just going to go -1, 0, 1, and remind myself that this is a closed dot at -1, but we're going to have an open dot here at 1. Okay, so x squared 1, 0, 1. So -1, 1 is a closed dot. 0, 0, 1, 1 is an open dot. So it's just this part of the parabola right there. And then finally, 2 minus x if x is greater than or equal to 1. So I want to include 1 and a couple numbers that are greater than 1. And these are going to be closed dots. So 2 minus 1, 2 minus 2, 2 minus 3. So 1, 1 is actually a closed dot inside that red dot. Okay, and then we have 2, 0, and 3, -1. And this is going forever to the right, so we're going to connect and go like that. Okay, so the question is to sketch the graph and determine the values of a which the limit exists. So the only place we have an issue is the limit of the green and the red at this point. They both are approaching 1, so that's okay. This is the only issue we have. As we approach from the right, the limit would be 1. As we approach from the left, this limit would be 0. So this is the only place the limit does not exist, and we're going to just say when a equals -1. That's the only place the limit doesn't exist. Everywhere else, the limit does exist. Okay, and a little help with number 35. We want to know the limit as x approaches 2 pi from the negative side, so from the left side of x cosecant x. So I'm going to just come over here to Desmos. Okay, and I typed in y equals x cosecant x. It's this weird blue graph. And then to kind of find 2 pi, it's kind of like, hey, we want to know when x is approaching 2 pi. But what you want to notice here, and I had to zoom out, I want to know as we approach 2 pi from the left side. So as I approach 2 pi from over here, it's -infinity. If it said 2 pi from the right side, it would be +infinity. So our answer is -infinity. For number 37, what you'll notice is if you try to plug 2 into this function, we would have 4 minus 10 plus 6, which is 0, and we're never allowed 0. We did not do one like this in class, but hopefully whenever you see trinomials, you think of trying factoring. So if I put x here and here, I need 2 negatives that multiply to 6 and add to -5. Okay, that's pretty easy. And then on the top, I need a positive and a negative that add to -2. So -4 and +2. Did I screw up? Okay, now I know. Okay, so we still kind of have this issue. If you plug a 2 in, you're going to see that this is going to equal 0, and there is nothing we can cancel. That would have made things a little bit easier, but we're approaching 2 from the positive. So let's think about what happens if we get really, really, really close to 2 from the right side. So like if we would plug in a number like that, okay, what's going to happen here, especially in the denominator? So do you agree this number is going to get really, really close to 0? So I'm going to write approach 0, and this is going to be about -1. So if we take 0 times -1, it's approaching 0. It's a really, really tiny number. This is going to be a tiny negative number on the denominator. On the numerator, we're going to have roughly -2 times 4, right? This is going to be close to -2 times 4, which is -8. So if we have -8 divided by a really tiny number, like -8 divided by -0.00000000001, you're going to get a positive infinity. And that's the answer to 37. And finally, number 39, I'll do in the next clip. And here's some help with number 39. So they want you to find the limit as x approaches 1 from the left and as x approaches 1 from the right. And they want you to, in part A, use a table of values. In part B, use that like tiny, huge concept. And then part C is the graph. That's definitely the easiest. So for part A, tables of value that approach -1 from the left and from the right. So here I'm approaching, oh, are these negatives? Oh no, +1. As I approach +1 from the left and the right. Sorry about that. Okay, so I have 0.98, 0.99, 0.999, and you can just type that into your calculator. I have -17, -33.7, -333.7. So this is approaching negative infinity. You can see that the larger the closer I'm going to get to 1, this is going to grow really huge. So negative infinity. So over here, if I plug a 1.1 into this, 3.02, 33.0, 333.0, and you can kind of see that's approaching positive infinity. So that's a pretty easy way to kind of see which way this graph is approaching from the left and from the right. Let's talk about that tiny, huge concept. So if we have 1 over x to the third minus 1, and I'm approaching 1 from the left. So like think of this being like 0.9999999. So the top's going to just be 1, but think of 0.99999 minus 1 is going to be a tiny negative number. So when you take 1 divided by a really tiny number, that's going to approach negative infinity because of the negative. Let's think of this concept as we approach 1 from the positive. So let's plug in 1 from the right side, like 1.00001 minus 1 is going to be a positive, really tiny number. So a positive divided by a tiny is going to approach positive infinity. And then you can see from our graph this is true. As we approach 1 from the left side, it's going to negative infinity, and as we approach 1 from the right side, it's going to positive infinity.